Hello, my dear students. In the previous classes, we have already discussed about the 12 principles of green chemistry. Today, we will discuss about green synthesis. Green synthesis is an efficient protocol for the synthesis of various biologically active compounds with diverse molecular structures. The chemical reactions under microwave ultrasound irradiation follows a green chemistry approach. By reducing reaction time, improvement in product yield, enhancement in rate of reaction, and reducing formation of waste. This technology is environment friendly by eliminating the use and generation of chemical hazards and utilization of renewable raw materials. Firstly, we can discuss about the synthesis of ibuprofen. Ibuprofen is a non-steroidal anti-inflammatory drug used for relief of symptoms of arthritis and also as an antipyretic and analgesic. The original boot synthesis in 1960 by Boots Chemical Company of ibuprofen consisted of the following 6 steps starting from the Friedel-Crafts acetylation of isobutyl benzene. Firstly, isobutyl benzene react with acetic anhydride in the presence of aluminum chloride. We get 4-isobutyl acetophenone. Then the 4-isobutyl acetophenone react with ethyl chloroacetate in the presence of sodium ethoxide. We get epoxide, followed by acetic hydrolysis and react with hydroxylamine. We get enoxame. The oxime reacts with the phosphorus pentoxide and removes a water molecule. We get a nitrile. Then, followed by acetic hydrolysis, we get the final product, ibuprofen. This is the synthetic method of ibuprofen used by Boots Company. This table shows the atom economy in the Boots synthesis of ibuprofen. We know atom economy is the conversion efficiency of a chemical process in terms of all atoms involved and the desired products produced. Here, total molecular mass of all the reactant is equal to 514.5, whereas the desired products molecular formula is only 206. That is, the waste products total molecular formula is equal to 308.5. That is, waste products are more than that of desired products. This synthesis results in large quantities of unwanted waste chemical byproducts that must be disposed of or otherwise managed. The above synthesis has about 40% atom economy only, and thus it is not a green synthesis. So, an improved synthesis by BHC company required only 3 steps. This improved synthesis produces much less waste and has a high atom economy. The synthesis starts with the acetylation of isobutyl benzene. The 4-isobutyl acetophenone produced is hydrogenated in the presence of ranitidine to get the corresponding alcohol. This is subjected to palladium catalyzed carbonylation to get ibuprofen. The BHC company synthesis of ibuprofen is shown in the figure. Table shows the atom economy in the green synthesis of ibuprofen by BHC company. Here, total molecular mass of the reactant is equal to 266. The desired product, ibuprofen, molecular mass is equal to 206. The waste byproducts molecular mass is equal to 60. Compared to Boots Company synthesis, the BHC company synthesis has less waste products. The overall atom economy is 77%, which is almost double that of Boots synthesis. Next, we can discuss about microwave assisted reaction. We know the microwave assisted reaction would have a marked influence in all areas of synthesis. Reduction of reaction time, improved yields, modification of selectivities, increased product purities, and simplification of workup procedure were described. and in most cases, these conditions and results could not be achieved by classical heating. This methodology can be included within the concept of green chemistry because the strong absorption of microwave irradiation by one component of the reaction would lead to shorter reaction times and improved energy efficiency. Moreover, the synergy with the solvent-free conditions, solid catalyst, and green solvents has expanded the green applications of this non-conventional energy source. Now we can consider an example. We know normally Hofmann elimination refers to the elimination reaction undergone by quaternary ammonium salts upon pyrolysis. Product depends upon the type of quaternary ammonium salts used in the high temperature process. The following Hofmann elimination is found to occur in a solvent system consisting of water and chloroform for extracting the product under microwave irradiation. Here, the quaternary ammonium salts convert into the product within 1 minute of microwave irradiation. Microwave irradiation has several advantages over conventional heating. These include homogeneous and rapid heating, spectacular accelerations in reactions as a result of the heating rate, and selective heating. Consequently, microwave-assisted organic reactions produce high yields and lower quantities of said products. Purification of products is easier, and in some cases, selectivity is modified. In the above example, the reaction is more energy efficient, occurs in a shorter time period, just 1 minute, and with a greater yield, approximately 97% than the conventional thermal process. This microwave-assisted reaction in water thus forms a much greener reaction than the pyrolytic process. Within about 1 minute, microwave irradiation raises the temperature of the polar solvent water to a temperature of 100 degrees Celsius, and Hofmann elimination reaction occurs in water. However, the product being much less polar than the reactant quickly partitions into the less polar chloroform layer, which by that time would have reached a temperature of about 48 degrees Celsius only. This lower temperature of the chloroform layer allows the isolation of the relatively unstable product in a very high percent yield, approximately 97%, about twice that of using conventional heating. Similarly, the Diels-Alder reaction shown below involves the 1,4 addition of the double bond of the maleic anhydride to anthracene in diglyme solvent. Conventional thermal process requires heating under reflex for about 1.5 hours. However, the same process takes place under microwave irradiation within 1.5 minutes with a greater percent yield. The microwave-assisted reaction is thus more energy efficient, quicker, and with a greater percent yield, and thus much greener as compared to the conventional thermal process. Next, we can discuss about ultrasound-assisted reaction. We know the word ultrasound has become common knowledge due to the widespread use of ultrasound scanning equipments in medical applications. Ultrasound refers to sound waves having frequencies higher than those to which the human ear can respond. High frequency ultrasound waves are used in medical equipments. The ultrasound frequencies of interest for chemical reactions are much lower than those used for medical applications, but the power used is higher. That is, the power ultrasound. Sound in the frequency region 20 to 100 kHz does have profound influence on many reactions. Conventional esterification reaction involves heating a carboxylic acid with an alcohol in presence of a small amount of mineral acid like sulfuric acid to get an ester. Here, ultrasound-assisted esterification reaction is shown. We know the esterification reaction is relatively slow under thermal conditions and the yield is very low. However, esterification reaction under ultrasonication is very much faster, takes place at room temperature, and gives greater yields of the ester, thereby qualifying to be called a green synthesis. Ultrasound-assisted esterification is utilized in the green synthesis of enzyme-catalyzed biodiesel production. Ultrasound-assisted alkaline hydrolysis of ester, that is saponification reaction, takes place at room temperature. The yields are much greater and the process is quicker as compared to thermal process of saponification. In accordance with the green chemistry principle, the ultrasound-assisted reaction is preferable. This is an example for ultrasound-assisted saponification reaction. Under ultrasonication, methyl 2,4-methyl benzoate undergoes saponification with 94% yield in 1 hour at room temperature as compared to the 15% yield obtained in the conventional process of heating with alkali for about 1.5 hours. Compared to traditional methods, the main advantages of the sonochemical process are milder conditions, shorter reaction time, and higher yields. Thus, the ultrasonic irradiation method has gradually been introduced in synthesis as a green synthetic approach that is safe for environment. Today, we have discussed about the green synthetic methods of ibuprofen. Moreover, ultrasound assisted reaction and microwave irradiation reactions. Thank you.